Gravitational potential energy. We have studied potential energy in last standard, and we have seen that the potential energy is due to the position or state of the object. Energy possessed by the object due to its position or state is called its potential energy. It is relative and it increases as we go to the greater heights from the surface of the earth. We had assumed that the potential energy of an object of mass m kept at height h from the earth's surface is mgh, where m is the mass of the object, g is the gravitational acceleration at the surface of earth, and h is the height of the object. Now this formula is applicable when value of h is small. We know that radius of earth is 6400 kilometers. So as compared to this value, when value of height is small, let us say 5 meter, 10 meter, 100,000 meter, at that time the formula mgh is applicable. But for large values of h, the value of g decreases with increase in value of h. For an object at infinite distance from the earth, value of g is 0 and earth's gravitational force acting on the object is also 0. So it is more appropriate to assume the value of potential energy is 0 at infinite distance. For smaller distance, the potential energy has to decrease, because we know that as the height decreases, potential energy decreases. So if at infinity it is 0, so at any other distance less than that, the potential energy should be smaller than that value. That means potential energy should be negative. And the formula is minus g m upon r plus h. Now this formula we take for granted without any proof. The proof of this formula is beyond the scope of the syllabus. Here capital M is mass of earth, small m is mass of object, r is radius of earth, and h is the height of the object from the surface of earth. We have seen that when a ball is thrown upwards, its velocity decreases because the gravitational force acting on that ball is in opposite direction of its motion. It's towards the center of earth. At a certain height, the velocity becomes 0, and after that the ball starts falling down and its velocity increases in downward direction. The maximum height reached by the ball can be found by Newton's third equation of motion, v square equal to u square plus 2as. Here we take the final velocity v0 because we know that at the highest point velocity is 0, and acceleration we take it as minus g because acceleration is in opposite direction of motion of the object. So we get equation 0 equal to u square minus 2gs, or s is equal to u square upon 2g. Hence the height reached by the object is u square upon 2g, where u is the initial velocity. So we can see that higher the initial velocity u, higher is the height reached by the ball. Now when the height is small, it's okay, but if the height is large, then we know that the value of g will keep on decreasing as we go higher and higher. So the force pulling the ball downward will decrease as the ball goes higher and higher. If we keep increasing the initial value of the velocity of the ball, then it will reach larger and larger height, and for a given specific initial velocity, it may escape the earth forever. That means it may able to break the earth's gravitation and continue its motion forever. An object going vertically upward from the surface of earth having initial velocity equal to escape velocity escapes the earth's gravitational force. the force of gravity being inversely proportional to square of distance becomes 0 only at infinity. This means that the object has to go to infinity so that the gravitation force acting on it is 0. Now let us find expression for this escape velocity. What is escape velocity? It is a minimum velocity that should be given to the object so that it breaks Earth's gravitational force. So if an object is released from the surface of Earth with escape velocity, kinetic energy will be equal to 1/2 mv escape square. Kinetic energy at infinite distance will be 0 because the object will come to rest at infinity. Potential energy at the surface of Earth is minus gmm upon r, whereas potential energy at infinite distance is again equal to 0. So total energy at infinite distance is 0, total kinetic plus potential energy. So by applying the law of conservation of energy, the energy on the surface of Earth also must be equal to 0. So this half mv escape square minus gmm upon r should be equal to 0. So if we simplify the formula, we get the escape velocity equal to square root of 2 gm upon r. And if we put the value of capital G and capital M and capital R in this, we get the value of escape velocity on the surface of Earth to be equal to 11.2 km per second. The spacecraft which are sent to the moon and other planets have to be projected from the surface of Earth with a velocity larger than escape velocity so that they can break Earth's gravitational force. Weightlessness in space. Space travelers as well as objects in the spacecraft appear to be floating. You must have seen the videos in which the people in the spacecrafts are shown floating in the air. So this is not because the value of gravitational acceleration is 0 at that height. For example, International Space Station is only at 400 km from the surface of Earth, and where the value of G decreases only by 11%. So it is not that G is 0 there. Then what is happening? Their weightlessness is caused by their being in the state of free fall. Though the spacecraft is not falling on Earth because of its horizontal velocity, every time it changes the direction, and the changes direction is a free fall. So here what is happening? The people in the spacecraft as well as the spacecraft both are in a free fall, and hence that spacecraft cannot provide a normal reaction to the people in the spacecraft. Hence they float. So floating is because of the state of free fall and not because G is 0 at that